Okay, the next type of problem that we're going to look at are called supplementary and complementary angle problems. And these are a type of problem that you'll definitely need to know how to do. Most instructors would put one of these on a test or exam. So what makes these problems somewhat difficult is that there's a lot of language and vocabulary that may be new to you. However, the nice thing about them is that there are some easy ways to structure the problem so that you can kind of treat them all the same way. So let's first talk about some vocabulary. This is coming from geometry, and we're going to be talking about the fact that if you have two angles, they are considered complementary if they add to 90 degrees. So complementary means two angles that add to 90, and here's a quick little visual for that. If you take a right angle and just throw in another little ray in there, that's going to create two separate angles here, angle A and angle B. And we know that angle A plus angle B form that right angle, so angle A plus angle B has to add to 90 degrees. Therefore, we would say that A and B are complementary. Now, if we know that, for example, A is 40 degrees, what does that force angle B to equal? Well, if we know they have to add up to 90, then that means angle B would have to be 50, since 40 plus 50 is 90. Well, what if angle A was 20 degrees? Then what does that force angle B to equal? 70 degrees. Another way of getting what angle B is equal to is by taking whatever angle X was and subtracting it from 90. So if angle A is 40, 90 minus 40 gives you 50. And that's kind of the key idea in these word problems. What we're going to do is we're going to let our original angle be X, and that forces the complement to be 90 minus X. That way the original angle plus the complement always add up to 90 degrees. Now another vocabulary word here that's very similar to complementary is the word supplementary. Now supplementary means two angles that add to 180 degrees. So if you think about just a straight line going across and a little ray that bisects it, here angle A would be over here and angle B might be this one right here. And angle A plus angle B form that straight line, and a straight line has a measure of 180 degrees. So again, we would say that angle A plus angle B is 180, therefore angle A and angle B are supplementary. So for example, if angle A was 80 degrees, then that would force angle B to be 100 degrees because we know that they have to add up to 100. So if angle A is X degrees, then what would angle B have to be? Angle B would have to be 180 minus X to force the two angles to add up to 180. So here's kind of the setup that you can always use for every supplementary and complementary angle problem. What you're going to be looking for is the original angle, always. So that's the one we don't know, that's the one we're going to call X. In the word problem, it may refer to the complement. So you know that the complement is always 90 minus whatever X is. And the word problem may also refer to the supplement angle, so the supplement will always be 180 minus X. So for example, let's look at a problem. Suppose the question says, find the measure of an angle such that the difference between the measures of its supplement and 3 times its complement is 10 degrees. So it's kind of confusing, there's a lot of stuff going on, but the very first thing you want to recognize is I see that word supplement and complement. So the first 3 things you're going to write down would be the following. The original angle, that's the thing I'm trying to find, and that's the thing we don't know, so that's going to be your X. If the original angle is X, then its complement has to be 90 minus X. That's always true for all of these problems. Similarly, the supplement has to be 180 minus whatever X is. That is always true for all of these problems. So this is the key stuff that you want to write down right off from the very beginning. Now what you're going to want to do is kind of translate this sentence into some words probably first, and then into some expressions second. So let's start translating. It says, find the measure of an angle such that the difference, well, we know difference means subtraction. And what is it that we're subtracting? Well, we want the difference between the measures of its supplement and 3 times its complement. Look for that word and. That's what's separating your two things being subtracted. So to the left of the and, or to the left of the subtraction, is the supplement. Just going to use words here first. And then to the right of the word and is 3 times its complement. So 3 times the complement. And what do we know about this? We know that it is, and is that keyword for equals, 10 degrees. So this has to equal 10. So the difference between the supplement and 3 times the complement is 10. So there's kind of our basic equation. And now all we're going to do is substitute in for this word supplement this expression, and substitute in for the word complement this expression. So the equation becomes 180 minus x. I'm going to use parentheses initially when I substitute in, minus 3 times the complement, and the complement's expression is 90 minus x. So here's our equation. That's the hard part, okay? Deciphering through the whole word problem, figuring out where the supplement and the complement need to go in the equation, that's the tough part. The easy part is actually solving this equation. So let's do that next. Now these first set of parentheses I don't really need because there's no number in front that needs to get distributed. So I'm just going to go ahead and drop those parentheses. But the second set of parentheses are necessary because I want negative 3 times this entire quantity. So negative 3 times 90 is negative 270. And then negative 3 times negative x becomes positive 3x equals to 10. Then on the left-hand side we have some like terms. So 180 minus 270 is negative 90, and negative x plus 3x is positive 2x. And now we want to get that x by itself, so let's add 90 to the other side. So we get 2x equals to 100. And to finish it off, divide by 2, and that tells us that x is 50. Now in these problems, you're always going to be trying to find out what that original angle is. And that's what we call x. So once you find x, you're done. You don't need to do anything extra. You don't need to find the complement or the supplement. So our original angle is 50 degrees. And there's our final solution. Okay? Let's try one more of these. Find the measure of an angle such that the sum of the measures of its complement and its supplement is 160 degrees. So again, I see that word complement and supplement. So automatically, you want to write down the following 3 things. We're looking for the measure of the original angle. So your angle is always just plain old x. If the angle is x, then its complement has to be 90 minus x to force these two to add up to 90. And the supplement has to be 180 minus x. So these 3 things are exactly the same as they were in the last problem. That's never going to change. The only thing that's going to change is how we translate this sentence into an equation. So let's do that next. What is it that we want to do? We want the sum, which we know means addition. We want to sum up the measures of its complement and its supplement. So look for that word and. There's your plus. To the left of the word and is complement. And to the right of the word and is supplement. So we want to add up the complement and the supplement, and that is, or equals, 160 degrees. So there's our basic equation. Now to get x's involved, we're just going to substitute in 90 minus x for that phrase complement or that word complement, and 180 minus x for that word supplement. So here's the equation that we need to solve. So to finish it off, 90 plus 180 is 270. Negative x plus negative x is negative 2x. We want to get the numbers together, so let's subtract 270 to the other side. And we're left with negative 2x. 270 minus 160 is going to be negative 110. And we see some negatives, but that's okay because when I divide through by negative 2, the negatives cancel out and we're left with x equals 55. So our original angle, which is what x is 55 degrees. Welcome to the lecture on solving word problems using linear equations, part 1. Today we're going to talk about how you solve word problems that have linear equations in them, and there's 6 guidelines that you usually want to apply whenever you're solving a word problem. The first step is obviously to read the problem carefully until you clearly understand what the problem is saying and identify what is to be found. Step 2, once you know what's to be found and what you're looking for, assign a variable to represent the unknown value. Write down what that variable represents. If there's multiple unknowns, represent them in terms of the same variable. Usually a diagram or a chart may help. Step 3, write an equation using the variable assigned. Step 4, solve the equation. Step 5, state your answer to the problem using a complete sentence. And step 6, check your answer in terms of the original problem. So in our first example, this is what I would consider a translation problem. We have a problem that's stated in English that we're going to translate into mathematical symbols in a mathematical equation. So the problem says if 2 is subtracted from a number and this difference is tripled, the result is 4 more than the number. Find the number. So first of all, we want to identify our unknown. We're looking for a number, so I'm going to call it x. Then we want to create an equation involving that x. So this is going to be determined by translating, going from left to right, basically that first sentence. So it says if 2 is subtracted from. Now right away when you see that phrase subtracted from, you need to remember that subtracted from requires you to switch the order around. So it is subtraction, but what comes in front of that phrase, which in this case is the 2, actually comes after the minus sign. So we're going to subtract 2 away from something. What are we subtracting it away from? We're subtracting it away from a number. So we're going to put our x in front of that minus sign. So 2 is subtracted from a number, becomes x minus 2. Keep reading. It says this difference is tripled. So a difference is subtraction. So right here is our difference. We want to triple it. So I'm going to multiply by 3. Now if I write it like this, that would be incorrect because that's only multiplying the x by 3. I want to make sure that I multiply the entire difference by 3, so we need parentheses. So 2 is subtracted from a number, and this difference is tripled. That's what we have so far. Then it says the result is, that means equals, 4 more than means plus or add, so 4 plus the number, and the number was our x. So here's our equation. 3 parentheses x minus 2 equals 4 plus x. And in words again, it was 2 is subtracted from a number. This difference is tripled, then the result is 4 more than the number. So here's our equation. That's the hard part. Setting up the original equation is usually the most difficult part of the problem. Now we want to solve it. So to solve this linear equation, we've got some parentheses. We want to get rid of them. So I'm going to distribute my 3 across the parentheses. That gives me 3x minus 6 equals 4 plus x. Now I want to get my x's together on the same side of the equation. So I am going to subtract x from both sides. That way I have 2x minus 6 equals 4, and these will zero out. My x is on the left side, so I need the numbers on the right side, so we're going to add 6 to both sides, and that'll leave me with 2x equals 10. And to finish solving for x, we want to get rid of that 2 by dividing, so I'm going to divide both sides by 2, and that tells me that x is 5. Now for our final answer, make sure you write your answer in a complete sentence. So the number is 5. And there we are. Okay, let's try another one. The next example. In triangle ABC, the measure of angle A is 141 degrees more than the measure of angle B. The measure of angle B is the same as the measure of angle C. Find the measure of angle A. So first, let's draw a triangle. We're talking about a triangle with angles A, B, C. We don't know what kind of triangle it is. It doesn't necessarily have to be a right triangle. We're looking for here the measure of angle A, but we also have mentioned angle B and angle C. So all three of these angles are unknowns. So I'm going to write them down, and one of these angles will be x. The other angles will be in terms of x. So if we read that first sentence again, it says the measure of angle A is 141 degrees more than the measure of angle B. So when you read that sentence, you want to kind of think about which angle would I like to know first. If I know, for example, angle B, then all I need to do to that is add 141 and I get the measure of angle A. So angle B determines angle A. So if I think about it that way, if we let angle B be x, then that will determine what angle A is. It's that same x plus 141 more. Okay? In the second sentence, it says the measure of angle B is the same as the measure of angle C. So if angle B is x, then so is C. Okay? So we now have the measures of our three angles in terms of x. What we need to do now to get our equation is use a geometry fact. The geometry fact is the fact that the sum of all the measures of all angles in a triangle is always 180 degrees. So this angle plus this angle plus this angle always have to add up to 180 degrees, no matter what kind of triangle you have. So knowing that gives me enough information to set up an equation. Angle A plus angle B plus angle C has to equal 180, so that becomes x plus 141, there's angle A, plus x, there's angle B, plus x, there's angle C, that has to add to 180. So there's my equation. That's the hard part. Now we just have to solve it. We have some like terms on the left side. X plus x plus x is 3x. And now I want to isolate the x, so I'm going to subtract 141 over to the right side. 180 minus 141 is 39. So I have 39 equals 3x. And to finish solving for x, we want to get rid of that 3 in front, so I'm going to divide both sides by 3, and we get x equals 13. Now here's another thing you want to be really careful about when you're solving word problems. You don't necessarily have the final answer once you find x. You want to make sure that you read the last sentence of the word problem, because that usually tells you exactly what they want to know for the final answer. And in this problem, we want to find the measure of angle A. So look back up here where we defined angle A. Angle A is an x. Angle A is x plus 141. So to get angle A, we need to take x, which we just found to be 13, add 141 to it, and that gives us 154. So our final answer is angle A measures 154 degrees. Just write your final answer in a sentence. Alright, let's try another geometry example. This next one deals with the perimeter of a rectangle. It says the length of a rectangle is 2 more than 3 times the width. If the perimeter is 28 inches, find the dimensions of the rectangle. So we're obviously talking about a rectangle. Let's draw a rectangle to help us visualize what's going on. We have a length and we have a width. And we want to figure out what these two dimensions are. So one of these is going to be x, and the other one is going to be something in terms of x. So let's look at this first sentence to figure out which one should be x. So it says the length is 2 more than 3 times the width. So which one do we need to know first? We need to know the width. Once we know the width, we can do 2 more than 3 times it, and that will tell us the length. So the variable that should be x is the quantity that you need to know first. So we need to know width first, so I'm going to call that x. And then we're going to translate 2 more than 3 times that. 2 more means 2 plus. 3 times means 3 times x. So the width should be x, and the length should be 2 plus 3x. You could also write this as 3x plus 2. The order here doesn't matter. Now they tell us that the perimeter is 28 inches. That's the extra piece of information we need to be able to set up an equation. And to do this properly, you have to remember how to find perimeter of a rectangle. Perimeter is the sum of all 4 sides of a rectangle. So one common mistake that students often make is they will take your width plus your length and set that to 28. That would be incorrect because that's only using the width and the length once each. You're only adding up 2 sides. We need all 4. So I'm going to use our perimeter formula for a rectangle, which says that perimeter is 2 times the length plus 2 times the width. And I'm going to substitute in what all these things are. The perimeter, they tell me, is 28. Then I want 2 times the length, and my length is this quantity 2 plus 3x. Notice I'm wrapping it in parentheses because I want 2 times that entire quantity. Then I need to add in 2 widths as well. My width was x, so I need 2 x's. So here's my equation. My perimeter, 28, is 2 lengths plus 2 widths. Now all we have to do is solve this. So since we have parentheses involved, I'm going to distribute across to get rid of the parentheses, and I get 28 equals 4 plus 6x plus 2x. We have a couple like terms on the right-hand side, so 28 equals 4 plus 8x. X is on the right side, so I'm going to get the numbers on the left side, so let's subtract 4. And I get 24 equals 8x. Divide both sides by 8, and we get x equals 3. Then remember to look at that last sentence to tell you what you're supposed to find. We want to find the dimensions of the rectangle, so that means we're looking for both the width and the length. So if we go back to our original rectangle over here, x was the width. So we just found x was 3, so the width must be 3. The length is 2 plus 3 times x. So 2 plus 3 times 3 is 2 plus 9, or 11. So the length is 11. So my dimensions of the rectangle are 3 by 11, and we were given units in this problem. The perimeter was given in inches, so I am going to leave space for those units. 3 inches by 11 inches, and that would be my final answer. So anytime you're given units in your problem, you must label your final answer correctly with units as well. Alright. Now the next 2 examples we're going to do are special types of word problems regarding supplementary and complementary angles. So a few definitions here to start us off. In geometry, we say that 2 angles are considered complementary if they add to 90 degrees. Okay, and we say 2 angles are supplementary if they add to 180 degrees. So, for example, if you have a right angle and I draw a little ray coming out, let's call this angle A and this angle B. Since they're forming a right angle, they must add to 90. So angle A plus angle B would be considered complementary angles. Likewise, if I have a straight angle going across with a little ray coming out, let's call this angle A and this angle B, then angle A and angle B add to 180 degrees because that forms that straight line. So angle A and angle B would be supplementary angles. Okay? Now in word problems, you will often see problems that ask you to find an angle, but at the same time they refer to that angle's complement or supplement. So whenever you see the words complement or supplement in a problem, you can usually always set up the problem exactly the same way. What you're going to do is you're going to let your original angle, the one you're looking for, that's always going to be the one we call x. The complement of that angle is automatically going to have to be 90 minus x. The reason it has to be 90 minus x is so that the angle plus its complement will be forced to add to 90. For example, if the original angle was 40, then 90 minus 40 would be 50. So 40 plus 50 automatically adds to 90, making sure that they are complements of each other. Okay, if you see the phrase supplement in the problem, then you're going to let the supplement angle be 180 minus x. And that again will force the original angle plus the supplement angle to always add to 180. Okay, so let's see an example. In this first example, it says find the measure of an angle such that the difference between the measures of its supplement and 3 times its complement is 10 degrees. Now, as soon as I read that problem, as soon as I see the word supplement or complement, I'm going to immediately write down the following 3 things. The original angle that we're looking for here, because remember we're trying to find the measure of an angle, that is always your x. The complement will therefore have to be 90 minus that x, and the supplement will have to be 180 minus x. You're always going to write down these 3 unknowns right away when you have a supplement or complement angle problem. Now once we've identified those 3 things, let's translate the original word problem using words, and then we'll substitute in using mathematical symbols. So we're trying to find the measure of our angle such that the difference means subtraction, the difference between the measure of its supplement and 3 times its complement. So we want the difference between 2 things. Look for that word and to tell you which 2 things you're finding the difference between. The first thing is the supplement, because that's to the left of that word and. So I want the supplement minus 3 times the complement. So 3 times the complement. And that is, or equals, 10 degrees. So in words, this is saying we want the difference, subtraction, between the supplement and 3 times the complement to equal to 10. So in words, that's what we have. Now all we have to do is substitute in using the appropriate variables over here. So wherever I had the word supplement, I'm going to substitute in this 180 minus x. Wherever I have the word complement, I'm going to substitute in 90 minus x. So that's going to go right here. Now don't write it just 90 minus x. You need parentheses around it because we want 3 times that whole complement. So here is our equation. The supplement minus 3 times the complement is 10. Whew, that's the hard part, setting up that equation. Okay? Once you get it set up, then we just have to solve. And the first step to solving here is getting rid of those parentheses by distributing not just the 3, but the negative as well. So I'm going to have 180 minus x, and then negative 3 times 90 is negative 270. Negative 3 times negative x becomes positive 3x. equals 10. Now I have some like terms on the left side. 180 minus 270 is negative 180, and negative x plus 3x is positive 2x. X is on the left side, so let's get the numbers on the right side. So I'm going to add 180. So I have 2x equals 10 plus 180 is 190. Divide both sides by 2, and we get x is 95. To finish it off, what are we looking for? In this problem, we were looking for the measure of the original angle, not the complement or the supplement, but the actual angle itself. So in these complement-supplement problems, usually you are looking for just x. So my final answer would be the angle is 95 degrees, whatever x was. And there's my solution. Okay, these are pretty tricky, so let's try another one. Okay, the next one says find the measure of an angle such that the sum of the measures of its complement and its supplement is 160 degrees. So as soon as you see either the word complement or supplement, you're going to write down three things. The original angle that we're looking for is always your x. The complement of that angle therefore has to be 90 minus x, and the supplement has to be 180 minus x. Those are always going to be the same three expressions no matter the rest of the problem. So anytime you have a complement or supplement problem, write these three statements down. Now we're going to write down the equation that we're talking about. So it says, find the measure of an angle such that the sum means addition. I'm going to look for that word and to find out what two things I'm adding. To the left of the word and is this word complement. So I want to add the complement plus, and right after the word and is the word supplement. So I am trying to add the complement and the supplement. And that is, or equals, 160. So the sum of the measures of the complement and the supplement is 160. So pretty simple equation initially with words. Now what we need to do is substitute in the appropriate expression for complement and supplement. So 90 minus x goes in for complement, and 180 minus x gets substituted in for supplement. So here's our new equation. 90 minus x plus 180 minus x has to equal 160. Okay, now to simplify. 90 plus 180 is 270. Negative x minus x is negative 2x. I have x on the left side, so I'm going to subtract 270 over to the right side. So I get negative 2x equals 270 minus 160 is negative 110. So when I divide, make sure you divide by the negative as well as the 2. We get x equals negative 110 divided by negative 2 is positive 55. Final answer. Remember, in these problems you're looking for the measure of the angle, the original angle, which will always be your x. So here the angle is 55 degrees. And we're done. Okay, so supplement and complement angle problems. Treated the same way, setting up the problem with these three initial statements. Angle x, complement is 90 minus x, and supplement is 180 minus x. That's consistently the same for every complement-supplement problem. The only thing that changes is the actual equation and the numbers involved in it. Okay, we're going to try one more type of problem in these notes today. This next type of problem is called a consecutive integer problem, and you often will see these in algebra. So first of all, what are consecutive integers? Consecutive integers are numbers that follow one another. Consecutive means one right after the other. So consecutive integers would look like -2, -1, 0, 1, 2, 3, 4. Notice each time you go up, you're going up by 1. You could also see consecutive even integers. So this would be -4, -2, 0, 2, 4, 6, 8, 10, 12, and so on. Notice each time these are going up by 2 every time. Consecutive odd integers would be -3, -1, 1, 3, 5, 7, 9, all those odd numbers. And again, these are also going up by 2 each time. From 1 to 3 is 2, from 3 to 5 is 2. So in word problems regarding consecutive integers, you are typically being asked to find 2 or 3 consecutive integers. So we're going to set up our problem based on how many numbers we're looking for and based on whether they're consecutive integers, consecutive even integers, or consecutive odd integers. So this is how you're going to set them up every single time. If you're looking for consecutive integers, you're going to let your first integer be x. To get the next consecutive integer, all you would have to do is add 1 to that. So the second consecutive integer would have to be x plus 1. To get the third consecutive integer, you would just have to add 1 more, so that would give you x plus 2. So anytime you're looking for consecutive integers, you're going to set up your unknowns as x for the first number, x plus 1 for the second number, and x plus 2 for the third number. Now how does this change if we're looking for consecutive even integers? It doesn't change too much. The first integer will always still be x, but this time to make sure that we get the next even integer, remember we have to add 2. So the second integer would be x plus 2, and to get the third integer we'd have to add 2 more, so that gets us to x plus 4. Okay, it turns out to be exactly the same for consecutive odd integers. Your first missing number will still be x. We have to add 2 more to that to skip over and get the next odd integer, and then we'd add 2 more to that to get the next odd integer, so x plus 4. So what's sometimes confusing for students is when they think of consecutive odd integers, they think you should be adding 1 and then 3 and then 5, but actually we're adding 2 and 4 and 6 and so on. You're still adding 2 even though it's an odd number. The difference between consecutive even and consecutive odd problems is that the initial number will either be even and then stay even, or it'll start off odd and stay odd. So let me show you an example. In this example it says, if 5 times the smaller of 2 consecutive integers is added to 3 times the larger, the result is 59. Find the integers. So the first thing you want to do when you read a problem like this is underline and identify what you're looking for. We are looking for 2 consecutive integers. So we want 2 numbers, first and second. The first missing number is your x. To get the second missing number, because these are strictly consecutive integers, not even and not odd, we only have to add 1 to get the next consecutive integer. So the first number will always be x, and in this case the second number would be x plus 1. Alright, now we're going to try to translate our equation. So we want 5 times the smaller of our 2 integers. Now which one of these is the smaller one? It has to be x, the one you start with. So we want 5 times the smaller, which would be 5x. Okay, continue reading on. It says, is added to, so we're going to add that to, 3 times the larger. So 3 times the bigger number is x plus 1, the second number. So when you write x plus 1, make sure you wrap it in parentheses because we want 3 times that entire number. Okay? So we have 5 times the smaller added to 3 times the larger. The result is, so equals 59. So here's our equation. Now we just need to solve it. So I'm going to start by distributing my 3. So 5x plus 3x plus 3 equals 59. Let's combine some like terms. 5x plus 3x is 8x. And I have my x on the left side, so let's subtract 3 to get the numbers on the right side. We get 8x equals 59 minus 3 is 56. Divide both sides by 8, and we get x equals 7. Now before you write your final answer, look at that last sentence to determine what they want to know. This one wants to know the integers, both of them. So if x is 7, remember the first number was our x, so the first number must be 7. So the second number is x plus 1, so the second number must be 8. So the two consecutive integers are 7 and 8. And there's my solution. Okay. Let's try one last example. Okay, it says if the first and third of 3 consecutive even integers are added, the result is 22 less than 3 times the second integer. Find the larger integer. Now that's a little overwhelming at first, but the first thing you need to identify again is the fact that we're looking for 3 consecutive even integers. So we want 3 numbers this time. So let me label them first, second, and third. The first missing number is always your x, and because we're dealing with even integers this time, if the first one's x, the next one has to be x plus 2, so that we skip over the odd one in between. And the third number has to be x plus 4. We have to add 2 more again. So my first number is x, second number is x plus 2, third number is x plus 4. So now we have our unknowns identified. Let's translate the sentence up above. It says, if the first and third are added, okay, so the first is x, the third is x plus 4. So we want to add x plus x plus 4, the first added to the third. The result is, that means equals, 22 less than 3 times the second integer. Now less than is one of those phrases, just like the phrase subtracted from, where you have to subtract in the opposite order. So less than means subtraction. However, since the 22 came first in words, it's actually going to come second after the minus sign. So we're taking 22 away from something. What are we taking it away from? 3 times the second integer. So 3 times the second integer was x plus 2. And I'm going to wrap that in parentheses because I want 3 times that whole number. So let's double check that we have the right equation. If the first and the third are added, the result is 22 less than 3 times the second integer. So we have it all set up correctly. Now we want to solve. Got a couple of like terms on the left side. X plus x is 2x plus that 4. And on the right side I can distribute my 3. 3x plus 6 minus 22. Couple of like terms on the right side this time. So 2x plus 4 equals 3x plus 6 minus 22 is negative 16. I'm going to subtract the 2x over to the right side so that I get a positive 1x. That minus 16 is still there and the 4 is still there. And now I'm going to add 16 to the left side so I get 20 equals x. Okay, now we want to answer the final question. The final sentence says, find the larger integer. So if x is 20, remember x is your first number. So the first number is 20. That means the second number must be 22, and the third number must be 24. We've got 3 consecutive even integers. One quick check to make here is that you better end up with even integers, otherwise something in your equation was wrong. Okay, which one of these do we want? We want the larger one. So the larger integer is 24. Okay, that concludes our lecture on solving word problems using linear equations, part 1. Good luck.